So we start with radical function. So the first thing we need to understand is what a radical function is. Now we need to get this because we started first from the first. We first talked about modulus functions. Okay, modulus functions. Even before this one, we had already talked about quadratic functions. So we are moving step by step and we finish all the functions. So if you remain, these are getting bulk and I have not seen people answering questions. Alright, so we are going to radical function. From radical functions, we are going to go to rational functions. From rational functions, we will continue going up to trigonometric functions, exponential functions, logarithmic functions, and such. So now when we're talking of radical functions, we're talking of functions which have got a root. In other words, root functions are what we call radical functions. For example, if you've got f of x being equal to the square root of x, such is a radical function. So the first thing we need to understand is, on all these functions we are looking at, we need to know how to sketch, how to find the domain and the range, and also how to solve some equations and inequations on those. So every topic on functions you look at, you need to understand those: domain and range, sketching, equations related to such a function. So when you're talking about such a function, if you want to sketch it, we can just pick any simple points. Now of course we need to know that we don't need to have anything which is negative inside there. We don't need anything negative. So if we have got x and we have got y, let's say if our x is 0, if we put 0 there, what will be our y? So that will be square root of 0, which will still give us 0. So if we put a 1 inside there, that will be square root of 1, that will still give us a 1. If we put a 4, that will be a square root of 4, that is going to give us a 2. So this we can sketch now. Okay. So we can now sketch this from the data that we have collected then. So we have got x and we also have y. So we have got 0, 0, and then we've got 1, 1. Okay. From 1, 1, we've got 4. Let's say this is 2, 3, 4. We've got 4, 2. So these are the points which we have. So we notice that our graph is going to move something like that and then continue going like that. So that is a radical function. That is the sketch of the function f of x is equal to the root of x. So that is a sketch. Now looking at this one, the domain, the set of x values permitted for this function, we are starting from here. There's no one to allow. Okay, so the x values, we can see that we are only starting from 0. We are starting from this point and then going towards this point. Those are the x values. And then the y values also, we are starting from here. We are going like that. Notice that we don't have anything. We don't have any negative x value and we don't have any negative y value. So we are only concerned with the positive part. Okay. So therefore the domain is from 0 up to infinity. Now notice that we are including 0 here because of that point. Same, the range also is from 0 up to infinity. So we are starting from this point going like that. That's the range. And then starting from this point going like that. That's the domain. Alright. So that is the first function we need to understand. The root of x. So from this one, whenever we see a negative in front, it means we've reflected our graph. For example, if we've got f of x being equal to negative root of x. So in this way, something that is like this, it means we've reflected our graph. So the graph now is going to be so we have got x there, then we've got y. So the graph is going to start from this point and then go in that manner. So it just tends downwards. Therefore, the domain for this one, the set of x values, we're starting from this one, going like that. Those are the set of x values. So always start from the smallest. So we're starting from 0 up to infinity. Now the range, the smallest y value we can have is down here, and then we are going, and the highest y value we can have is this point, which is here. Okay, so we are going like that up to there. Note that this graph will continue going down. It will continue going like that as you increase the values of x. So that is what we are talking about. Now when you are showing the domain and the range, you start with the smallest. So the smallest we can have is negative infinity, and the highest we can have for y is 0, because we can't exceed to go this way. Okay, up to 0. So that will be the range for that function. Again, I want to mention this. Note that the inside of the root should always be positive. Very important point to know. The inside should always be positive. So now, what does it mean if we have got a function which has got a negative inside? For example, if we say f of x is equal to the root of negative x. So what we have there, we always want the inside to be positive. So what should we do for us to make the inside positive? We need to multiply this portion, which is negative, with a negative sign. And multiplying with a negative sign means we are only getting the negative portion of the x values. Because whenever we get an x value which is positive, the inside will be negative. Such as if we get, let's say, a positive 1. If we put here positive 1, that will be negative times positive 1, that will be negative 1. And we don't have a root of a negative 1. That will take us into the set of complex numbers, and we don't want to go in that set. We are still in the set of real numbers. So the only way that we are going to make this positive is to multiply it by another negative. So this function is only valid for x values which are negative. And so sketching this graph, so we are going to have x there, then we've got y. So this graph is going to start from this point and then move like that if we have got a negative inside the root. And so for this one, the domain, the set of x values permitted, is from here up to 0. So those are the x values permitted. So it is from negative infinity up to 0. We are including 0, but we don't include negative infinity. And then the range of values, we are starting from here going upwards. Those are the y values which are permitted for this function. Therefore, the range is from 0 up to infinity. So that is for such a function. Now, what if we have got a negative outside and a negative inside? How does the function become? So if we have got f of x being equal to negative root of negative x, so what is important for us to note is the inside should always be positive, and so we just need to take the negative portion of x. Now, because we've put a negative also outside, it means we are reflecting our graph. So this graph then tends, it will be in this region. That is, the negative inside there will be catered for the negative portion of the x-axis. And then this negative will be catered for the negative portion of the y-axis. Okay, so that will be the graph. Now, what if we start adding some constants to this, our general function? Like, for example, if we say the root of x plus 4. Now, a constant added to the outside means we are shifting our graph in the y-axis. So this is a phase shift. This is a shift of the graph in the y-axis. It's either up or down, so we call it a vertical shift. So that means we are going to shift our graph 4 units upwards. So our graph is going to start from here and then move like that. So if this graph had a negative here and then we added the 4, this our graph would have been like down like that. Okay, so in this case, let's start with a red one. So the red one, we are just taking this portion without the negative sign. So we are taking this equation, f of x is equal to root of x plus 4. Now, what's the domain and the range for this one? So the domain, the set of x values, notice that we are starting from this point going in this direction. So this point x is 0. Okay, so from 0 to infinity, that's a domain. Now for the range, notice that we are starting from 4, and then the graph will be going upwards as we increase x. Okay, and so it is from 4 to infinity. That will be the range. Now let's go to the yellow one which we've drawn. This is the graph for f of x is equal to negative root of x plus 4. So for this one, the domain, the set of x values permitted is also from 0 up to infinity in that way. And then now the range, the smallest y value which we can have is negative infinity. And then the graph is going like this until it reaches this point where our y is equal to 4. And so it is from negative infinity up to positive 4, like that. So that will be the range for our function. Okay. Now let's see if we add some other constants. Let's say we add this certain constant inside the root. What does that mean if we add something inside the root? So let's say if we've got y, which we can also say f of x, being equal to the root of x minus 4. So if you've got something that is like that, we need to equate what is inside the root to 0. So that will be x minus 4 being equal to 0. And that will give us x being equal to positive 4. So that means our graph has been shifted. Instead of it starting from 0, it's going to move 4 steps to the front. So it will start at the positive 4 mark. So that is x, that is y. So our graph is starting from 4. And then from there, it's going to go in that way. So if this is our graph at the negative here, it means our graph is going to start from here and go in the down direction. So now what is the domain? So this one is y is equal to the root of x minus 4. So the domain for this one, the x values allowed, we are starting from 4 going in this direction. Those are the x values allowed. So from 4 to infinity. And then the range, the y values were starting from this point going up. And so it is from 0 to infinity. Now if we come to this red line I've drawn, which is y is equal to negative the root of x minus 4, the domain, the set of x values is starting from 4 to infinity, of course. The range, the smallest we can have is negative infinity, and then it's going up to the point 0 there. So therefore the range is from negative infinity to positive 4. So positive 4 is inclusive, negative infinity is not included. So that is the graph then for that one. Okay, let's look at another thing. Okay, so it is positive 4 because we are equating what was inside the root to 0. So it was root of x minus 4. So we equate this to 0. That is x minus 4 is equal to 0. So that gave us x to be equal to positive 4. So it is at positive 4 where we are starting. Okay. Oh, I had included 4. That was supposed to be 0. So it was like this. So the range is starting from 0. I mean from negative infinity up to 0. That wasn't supposed to be 4. That was supposed to be 0. Yeah. Okay. Now, we can look at another function. Let's say if our f of x is equal to 2 root x. What does this 2 mean? Okay. So this 2 is the amplitude. So that 2 is the amplitude. For example, you know that if you've got, let's say y is equal to root of x. If our x is 0, we put 0 there, our y will also be 0. If our x is 1, our y will also be 1. If our x is 4, our y, if we put 4 there, root of 4 will give us a 2. But if we are saying y is equal to 2 root x, let's say we've got x there, we've got y. If we put a 0 inside, it will be root of 0 times 2, which will still be 0. if we put a 1, so we notice that it will be root of 1, which will give us a 1, and then 1 times 2, it will give us a 2. So if we put a 4, it will be root of 4, that will be a 2 times 2, which will give us a 4. So if we put a number there, here, in front, it means we are increasing. Okay, I don't know what word. Let me first show the sketch, and then I see the word which I can use. So if this is our x, this is our y. So we are talking of this point here. We've got 0, 0, and then 1, 2. From 1, 2, we've got 4, 4. 1, 2, 3. Okay, that's 4 here. And then we've got a 4 there. So we've got this point and also that point. Notice that our graph has gone a little bit higher, because the actual one was supposed to move like that, something like that, but this one has been moved a little bit higher. So when we put a constant here, we shift our graph in the we don't shift it, but we make it much more elongated. Instead of it being more curved, becomes more elongated. That's the meaning of a constant we put in front there. It really doesn't change anything of this graph, it's just that it makes it much more elongated. Okay. So in this case, the domain is still starting from 0 up to infinity. The range is still also starting from 0 up to infinity. So it's not different. Okay. Okay, the domain. All right. So that graph was like this. So when we're talking of the domain, a set of permitted x values, you are starting from this point, going like this. Notice that we don't have anything on this region. For x, we don't have anything. So it won't be part of the domain. So the domain, we are only starting from 0. Of course, we are including 0 itself, because the point is starting from there. And then up to infinity, because we are going to the forward. Same with the range. We are starting from here. Now for the range, it's just that we are going up. So we are starting also from 0 up to infinity. In that way. Okay. Yes. Okay. So what if we have got y is equal to negative, let's say 4 minus the root of x minus 4? How do we sketch such a graph? Okay. So I've got our x and our y. So the first thing is we need to equate what is inside to 0. So let's equate that to 0. That is the x minus 4 should be equal to 0. We are finding that x is equal to 4. So in other words, we've shifted our graph 4 units to the right. And then this constant 4 we are seeing means we have shifted our graph 4 units up. So the graph is going to start at this point. Now, is it going to go up or is going to go down? That has to do. Okay, we've got 4 and then 4. So the graph is going to start from there. Now, this function is negative. Notice the negative which is here. So because it's negative, it means our graph is going to go downwards. So the graph is going to start from this point and then move like that. So that would be the sketch of the graph. So we can actually find the point where the graph has cut the y-axis. We know that at that point our x is equal to, our y is equal to 0. So we can actually find that point. So we can say we want the point where our y is 0. So that would be 0 is equal to 4 minus the root of x minus 4. So we can take the root this side, it becomes positive root of x minus 4 is equal to 4. So we can square everything. So that will give us x minus 4 is equal to 16. And then that will give us x is equal to 16 plus 4. X will be equal to 20. So at this point where it has cut, that should be at 20. Okay. So that is a graph. Now the domain for this one, the set of x values permitted, we are starting from this point going like that. So the domain is from 4 to infinity. Now the range of values permitted for this one, notice that the smallest we can have is down here. So we are starting from the down going up to the highest y value we can have is 4. So the highest is always this side. Now the smallest we can have is negative infinity. So that will be the range. Are there questions over this? Over sketching? Alright. Okay. So for the range, you are talking of all the y values for which the function is going to work. Let me just try to clean up. So range, the function is starting here. So the range of values, the smallest y value we can have is negative infinity, because the graph will continue going down as long as we increase the x values. It will continue going down, and the highest we can have is 4. So it is from negative infinity up to positive 4. And when you are writing the domain of the range, always start with the smallest number. Of course, we know that when you are using set interval notation, always start, you have a comma b. A is always smaller than b, so that's why we are starting from negative infinity up to 4. That is the range. Alright. Okay, now having understood how to sketch this diagram, let me just look at the last example and then we do some equations of radical functions. Let's say we've got f of x being equal to the root of 2x, okay, plus 6, then minus 3. How do we sketch such a function? So when we want to sketch this function, the first thing is we need to consider what is inside the root there. We equate it to 0. That 2x plus 6 should be equal to 0. That means 2x should be equal to negative 6, and our x should be equal to negative 3. So that is a shift of the graph in the x. Our graph has been shifted 3 units to the negative. So we've got x there, we've got y. So 3 units to the negative, so we are starting at negative 3. Now notice that even this region, let me use a different number because the person might think, which one are we using? Let's say this is negative. Let me use 5 here. Now this negative 5 means we've shifted our graph negative 5 units downwards. So negative 5. So our graph is going to start at this region. Now the next thing we need to consider is this function positive or negative? So what we can see is the radical is positive. We don't have a negative in front here. So if it was negative, it would have been going downwards. But because it is positive, okay, because our radical is positive, it's going to go like that. Now I've made it to pass through 0. I don't know if it is going to pass at 0. Okay. So for us to tell where it is going to pass, what we can do is, for such a problem like this, where we don't know where it's going to pass, let's say if our y is 0, what will be the value for x? So that will be 0 is equal to the root of x, 2x plus 6, then minus 5. We take the 5 over the other side, so that will be 5 is equal to the root of 2x plus 6. And then we can square everything. That is going to give us 25 is equal to 2x plus 6. We take the 6 over the other side. 25 minus 6 is equal to 2x. So that is going to give us 19 is equal to 2x. And then x is going to give us 2 can go into 18. I mean, is it 9 times? 9.5. So when our y is 0, our x is going to be 9.5. So what does that mean? So let me try to remove this. So that means if our y is 0, x will be somewhere here, 9.5. So this graph is going to start from this point, go something like that, and then pass at that point, and then continue. We can actually find also this value where our x is 0. We can put a 0 here. So that is going to give us a root of 2 times 0 is 0, and then 0 plus 6 will give us 6 minus 5. So root 6 minus 5 is a negative number, so we can find that this is the y value when x is 0, which is at this point. So this is root 6 minus 5. Okay, so that is how we basically sketch radical functions. So we are done with sketching, and you've seen how we find the domain and the range. So for example, if they just asked you to find the domain and the range, you don't know how to do it, you can simply try to just make a sketch for a radical function. So what we are saying is, if you've got something like this, of course we have said if you want to sketch this, equate the inside to 0, that will be 2x plus 5 is equal to 0, that will be 2x is equal to negative 5, and our x is equal to negative 5 over 2. So it means our graph is going to start at negative 5 over 2. Because it's positive, it will start moving like that. So we can actually find the domain of this one without even sketching. So the domain, what we want to make sure that inside the root, it should always be positive. So we don't want this. The negative root of a number, we don't want it. We always want inside to be positive. So we always want it to be positive there. So what numbers are positive? If you've got a number line, you've got 0 here. Numbers which are this side are positive. So that means any number which is greater than or equal to 0 is positive. So we always want our inside root to be positive. So that means our 2x plus 5 should always be greater than or equal to 0. So that means our 2x should always be greater than or equal to negative 5. That means our x should always be greater than or equal to negative 5 over 2. Now, what numbers are greater than or equal to negative 5? We are starting from here, going like this. Those are the numbers which are greater than. So therefore, our domain, this is the domain. We can write it like that, or we can write it as from negative 5 over 2 to infinity. Which we can also say the domain is x, such that x is a real number. Okay. Now this real number is always greater than or equal to negative 5 over 2. So we can also write like that. I don't know which one would prefer. So x is a member of real number such that our x is greater than or equal to negative 5 over 2. Or you can first sketch and then see where the graph is going. Now looking at this one, our range, the smallest y value we have is 0, because on this line our y is 0. So it's from 0 and then it's going upwards. So 0 to infinity. So that is going to be our range. Okay. Now let's see, how do you solve a radical equation? If you've been given the root of x minus 4 minus, let's say, 6 is equal to 0, how do we solve such an equation? So what we can do is we can introduce a square on both sides of the equation. Now this one, where there are two of them, it would be better you take one this side, okay, so that you just remain with one over the other side if there are only the two of them. So that will give us root x minus 4 being equal to 6. And then now square the left hand of the side of the equation and also the right. So this root and the square are going to cancel. We're going to remain with x minus 4 being equal to 36. And that is going to give us x to be equal to 36 plus 4. And that means our x is going to be equal to 36 plus 4 is a 40. So we can actually confirm that if we say root of 40 minus 4 minus 6. Root of 40 is, root of 40 minus 4 is the same as root of 36 minus 6. The root of 36 is a 6. 6 minus 6 is a 0. So which confirms our equation. So that is how we can solve such a basic one. So in the same way, we can solve, if they've given us the root of x plus 1 is equal to the root of x minus, let's say, 2. How do we solve such an equation? So we can actually square both sides also. Now please, this portion we are squaring the 2 together, not alone. And then this side we square also like that. So please don't square these, you square this one alone, that one alone. Okay. So this is going to give us, now root x plus 1 squared is going to be the same as root x plus 1 and then root x plus 1 again. And this should be equal to the root of x minus 2 squared will simply give us x minus 2. So if we distribute this by the distribution which we know, is going to give us x. First it will give us root x and then plus 2 root x and then plus, okay, this will be root x squared plus 2 root x plus 1, and that will be equal to x minus 2. So the root of x squared is going to give us x and then plus 2 root x plus 1, and that will be equal to x minus 2. So we can see that this x and this x, if they go to the same side, they are going to cancel out. So we're going to remain with 2 root x being equal to negative 2. We can take this one that side minus 1. So that is going to be 2 root x is equal to negative 3. We can divide by a 2. That will give us root x is equal to negative 3 over 2. So at this point, we are going to see that our x, actually we can now square everything again. Square this side, also square that side. So our x is going to be equal to negative 3 squared is a 9, 2 squared is a 4. So that will be it for that one. So it is the same knowledge which we can use for different kinds of equations which we can deal with as long as they are radical. Let's look at another example, we see what we can do. Pardon? Yes. Yeah, we can. We can also use a graph now, because at times it might give fractions, so we might not get the exact value unless you are using something which is maybe a graph paper or something like that. Now because they're giving us also fraction answers, you might miss out something. Alright, so let's say if you've got root x plus root x minus 1 is equal to root 2x. How do we solve such an equation? So we square also both sides. So this is going to give us the root of x squared if we expand, and then plus 2 the root of x times the root of x minus 1, and then plus the root of x minus 1 squared, and that will be equal to the root of 2x squared will give us a 2x. Is this okay? Do we know where these are coming from? So this is going to give us x plus 2 root x minus 1, and then plus, if we square this portion, we are going to get x minus 1, and that will be equal to 2x. So from here we can multiply what is inside the roots there, we can multiply them. And notice that if we add this x and this x, it will give us 2x, and then this 2x is going to cancel with that 2x that side. So what we are going to remain is only 2. If we multiply that x with the other one which is inside the root, And then we are remaining with a minus 1, and that will be equal to 0 because the x and the 2x side has cancelled. So this is giving us x minus 1, and that is being equal to 1. So we can divide through by a 2, that will give us the root of x squared minus x, and that will be equal to 1 over 2. So at this point we can square also both sides. That is going to give us x squared minus x being equal to 1 over 4. Like if we square 1 to give us 1, if we square a 2, that will give us a 4. And then at this point we can take the 1 over 4 over the other side. That will give us x squared minus x minus 1 over 4. That is going to be equal to 0. Now to make this as a as numbers instead of a fraction, let's multiply it by 4. So 4 times 4x squared, that will be 4x squared minus 4x minus 1, and that will be equal to 0. Now are we able to factorize this function which we have here? If we can't factorize it, then we can use the quadratic formula. Okay, so let me just write here 4x squared minus 4x minus 1, that is being equal to 0. So what we are seeing, the product here, if we multiply 4 by a negative 1, we are getting negative 4. And then the sum is also negative 4. Do we have two numbers? If we multiply them, they give us negative 4. And if we add them, they give us a negative 4 also. So of course, if we talk of 2 and 2, negative 2 minus 2, it will give us a negative 4 as a sum. But if we multiply them, they will not give us a negative 4 as a product. It will be a positive 4. So we don't have two numbers which can do that. So this one can't be factorized. So what we can do is we can use the quadratic formula. X is equal to negative b plus minus root of b squared minus 4ac divided by 2a. So that will be negative, our b is negative 4, plus or minus our b, which is negative 4, we square it minus 4, the a is 4, and then the c is negative 1, divided by 2a, which is 2 times 4. So this is going to give us positive 4. Okay. Sorry, just a moment. Alright, so that is going to give us positive 4 plus or minus 4 squared inside the root, that will be 16. 4 by 4, that is 16, negative 16, plus 1, that is positive 16. And then over 8. So if we bring here, our x is going to be equal to 4 plus or minus 16 plus 16 is the root of 32 divided by 8. So this is 32. Okay, so 32 can also be written as 16 times 2. If we don't want to have fractions as our answers, so I mean decimals, so that will be 4 plus or minus, so the root of 16 is the same as 4 root 2, and then divided by 8. So at this point we can split them. What we can have is 4 plus 4 root 2 over 8, or x is equal to 4 minus 4 root 2 over 8. Now we can factorize out a 4. That will be x is equal to 4 open brackets 1 plus root 2 over 8, or x is equal to 4 open brackets 1 minus root 2. Don't know if you can see that inside there. So that is 1 minus root 2, and then over 8. So at this point we can just reduce. So that means our x is equal to 4 into 4 is 1, 4 into there is 2. So that is 1 plus root 2 over 2, or x is equal to 1 minus root 2 over 2. So those are the two x values which we can have. Okay. If we want, we can convert them to decimals. Is that okay? Yes. It is fine. All right. If we don't have questions, we are going to end here. So we've looked at how to sketch, how to find the values of x given an equation. So of course we know how to solve inequalities. We use the same knowledge even if you have an inequality for a radical function. I'll give a very basic example. The root of x minus 1, let's say plus 1, is greater than or equal to the root of x. So square both sides. So that is going to give us x minus 1 and then plus 2 root x minus 1 plus 1, and that will be equal to x. This x, that x are going to cancel. This negative 1 and that 1, they also cancel. So before they cancel too much, let me use a different value so that we understand. Let me use 2 here. So this means that this will be 4 and then this will be 4 also. Okay. So that is what we have. Of course, this x and this x is going to cancel. And then we are going to remember 4 root of x. I've put equal to, it's not equal, that's greater than or equal to. Now negative 1 plus 4, that will be positive 3. That should be greater than or equal to 0. So that will give us 4 root of x minus 1 greater than or equal to negative 3. We divide by 4. The root of x minus 1 is greater than or equal to negative 3 over 4. Okay. Now from here we want to remove the square root. Okay. We want to remove the square root. So what we do is we are going to square both sides. If we square both sides, what we are going to have is x minus 1 is greater than or equal to 9 over 4. Now I want us to hold first this sign which is here. We see what is going to happen. So x, we are finding that x should be greater than or equal to 9 over 4 plus 1. So that is x is greater than or equal to, that should be 13 over 4. Now if we get our number line, we've got 13 over 4. 13 over 4 is approximately 3 point something. Okay. So we are saying greater than. That means our graph is going to work for values of x which are in this way. So let's say we get a number such as, what number can we get? Let's say we get a number, anything that which is above 13 over 4. 13 over 4 is about, is it 3? Because 4 into 12 is 3. So it's 3, 1 over 4. That is 3.25. Okay. So let's say if we get a 4, we put in this, what will be the behavior of the function if we get a 4? So if we get a 4, we put here, that will be 4 minus 1, which will be a 3. So that will be root of 3 and then plus 2. And we want that to be greater than or equal to the root of x. And in this case, we have gotten a 4, that is the root of 4. Now, the root of 3, I don't have a calculator. I don't know if anyone has a calculator. Okay, thank you. So the root of 3 is 1.7. And 1.7, if we add the 2, we are going to get 3.7. Of course, that is greater than or equal to what? The root of 4, which is a 2. It is greater than. So the values which are this side are indeed working. Okay. They are working. So we can get another value such as, let's say we get 13 over 4 itself. We put it inside here. where there is x. So that will be 13 over 4 minus 1. And then we take the square root of that. We are finding 1.5. And 1.5 plus this 2 which is here is giving us 3.5. Now, is that greater than or equal to, let's come here, the root of, remember we used 13 over 4. So the root of 13 over 4 is 1.8. So actually this is also true. So we see that those values are going to work. Now notice that the only values which can work inside here are positive values. Because if we have got negative values, we don't have the square root of a negative number. So that is how we solve also radical inequalities. Unless there is a question. Yes, they can ask to find the range if it is. So these questions will be connected. So there's a portion which they only ask for inequalities and equations. And they can also give you another part where they say find the range and the domain, sketch the function, such a thing. So that is all for now. Hope we've gotten it. See you next time when we'll be talking about rational functions. Now the badness is you people don't answer questions, so I'm not leaving any questions. Alright. Last time I left questions, no one answered. Okay. Alright, so those are the questions we can try out. Thank you so much for being present. Enjoy your week.